现在是我的4点半起来礼貌。刷好来了，我现在我要换衣服。换衣服。现在我要开始复习数学。今天我要学习19课 ，symmetry 是。The front of this museum in Ho Chi Minh City in Vietnam is semi-circular. If you draw a vertical line through the center of the building, from the center right, the left side will be a mirror image of the right side. 等一下，是不是真的？算了，画不。The front of the building, the photograph is circular. One half of the building is the image of the other. The line divided the building into two halves. It is called the mirror line or line of symmetry. Shape or object that can be divided into two or more parts, which are identical in shape and size, are said to be symmetrical. Symmetry is found in both two-dimensional shape and three-dimensional object. In this chapter, you are going to learn to know about symmetry, about line and turning or rotation symmetry in both two-dimensional shape and three-dimensional object. Symmetry in two dimensions. There are two types of symmetry in two-dimensional shape: line symmetry, rotation symmetry. Line symmetry, if a shape can be formed so that one half fits exactly over the other half, it was line symmetry, also called reflection symmetry. If you mirror on the one line on shape A, the view in the mirror will be for that whole triangle. The line called the line of symmetry or mirror line of the shape. Shape can have more than one line of symmetry. Now I'm going to do the practice. Okay, finish this part. Rotation of symmetry. Rotation symmetry. A rotation is a turn. If you rotate a shape through 36 a 360 degree, keeping in its center point in a fixed position, and fit into itself except at various positions during the turn, then it has rotation symmetry. The number of line fit onto itself during a full revolution the is the order of rotation symmetry. The diagram shows how square fit oneself four times when it is turned into 360 degrees. The dot in the center of the square is the center of rotation. This is the point when around which it is turning. The star shows the position of one corner of the square as it turns. Symmetry in three dimensions. There are two types of symmetry in 3D dimension. Plane symmetry, rotation symmetry. Plane symmetry of a plane is a flat surface if you can cut into a solid in half so that each half is the mirror image of each other. Then the solid has a plane symmetry. This diagram of a cube shows that it can be cut in three different ways to make two diagonal halves. The shape area of each diagram represents the plane of symmetry. Doing the exercise, checking the answer. Rotation of symmetry. Imagine a road through a solid shape. The road forms an axis from the shape to turn around. If we rotate the shape around the axis and it looks the same at different points on its rotation, then the shape has rotation symmetry. The road is then the axis symmetry. The road then is the axis of symmetry. Symmetry property of circle. A circle has line of symmetry about any diameter, and it has rotation symmetry about its center. From this fact, a number of results can be disputed. The perpendicular bisector of a chord passes through center. Each chord are equidistant from the center, and the chord equidistant from center are equal length. Two tangent rods to a circle from the same point outside of the circle are equal in length. The perpendicular bisector of a chord passes through the center. The perpendicular bisector of chord A and B is the locus of point equivalent from A and B. But center O is equivalent from A and B. O and A and OB are radii of center with center O. O must be on the particular bisector of AB. This result can be expressed in other way. The perpendicular from the center of a circle to a chord meet a chord at its midpoint. The line joining the center of a circle to the midpoint of a chord is perpendicular to the chord. You can use this fact to find the length of chord and the length of side to right angle triangle drawn between the center and the chord. Calculator. I go to take calculator. Okay. 8x equal to 6.5 minus 6 squared. 6.5 squared minus 6 squared equal to 6.25 square root 6.25 equal to 2.5. AB equal to 2.5 times 2 equal to 5. X square equals to 17 square minus 8 square. X equals to square root 225 square root 225 equal to 15. X equal to 15. AB equal to 15 times 2. AB equals to 30. Oh, yes. Hmm. Let me check it's correct. Yeah, it's correct. Let me continue. Bx equal to 1.5 squared minus 0.9 squared. Square root 1.44 square root equals to 1.2 equal to 1.2 times 2. AB equal to 2.4. Angle relationship in circle. Circle have many useful properties that can be used to solve problems. You will now explore more of this property. The following example of theorem will help you to solve problems involving angle and circle. The angle in a semicircle is a right angle. The angle between the tangles and the radius is 90 degrees. Calculator. Oh, 检查。对呀。 Alternate triangle theorem. You already know there were a triangle and a diameter of the circle. They meet each other from a right angle. The diameter will divide the circle into two semicircles. You also know that a diameter of any circle is a chord that passes through the center of the circle. When the chord meets a triangle but do not pass through the center, the circle is divided into major segment and minor segment. The point which the tangent and the chord meet is called the point of contact. Investigation. Draw three large circles. Draw a tangent to each circle, taking care to be accurate as possible. Your line should only touch the circle once. Draw a chord so that it meets the triangle. Draw an angle between the triangle and the chord. You can choose each angle. Work out which segment is the alternate segment and draw an angle in it. Measure as accurately as you can both the angle and the angle in the alternate segment and the angle between the tangent and the chord. What do you notice? The alternate segment theory states that the angle between the triangle and chord is always equal to the angle in the alternate segment. The diagram shows which angle are which angle to which. Proof of the alternate segment theorem. This is an interesting proof because it will use some of the theorem that you already know. Begin by drawing the circle, chord, tangent, and angle in the alternate segment called the angle y, x, and y respectively. You know that any two angles drawn in the same segment are equal. This means you can draw another angle in the alternate segment using the diameter as one of the line forming the angle and know that it's still equal to triangle BAD is right angle and is the angle in semicircle. This means that angle ABP must be 90 degree minus y. You, you also know that the angle between a diameter and a triangle is 90 degrees, so 90 degree minus y plus x equal to 90 degree. This is show that x equals 1. Doing the exercise now. to tell my mother to wake up now.妈咪起来了，5点10分了。Wake up already, teacher. Sister, wake up. Now I continue to do my exercise. Now I'm going to read the 23 chapter. Vector and transformation. Transformation deal with moving or changing shape in a set way. You are going to revise what you know about transformation, use vector, and work with more precise mathematical during the discussion of transformation. Simple plane transformation. Transformation make change. In mathematics, transformation is a change in the position or a side of a object. In this section, we will deal with 4 types of transformation: reflection, a flip or a mirror image, rotation, a turn, transition, a slight movement, and angulation, making the object larger or smaller. Transformation produces an image of the original object in a new position or a different size. A point P on the object is labeled as P prime on the image. Reflection, rotation, and transition change the position of an object, but they do not change the size. So the object and its image are congruous. If you place the object and its image on top of each other, they coincide exactly. When you enlarge an object to change its size, the object as its image are similar. In other words, the length and of corresponding side on the image are the same proportion as on the object. Reflection is a mirror image of the same. The line of reflection is called a mirror line. Corresponding point on the object and the image are same distance from the mirror line. These distances are always measured perpendicular to the mirror line. Property of refraction. A point and its image are equivalent from the mirror line after reflection over the line M. The mirror line bisects the line joining a point and its image at right angle. The line segment and its image are equal in length. AB equal to AB point. The line and its image are equally introduced to the mirror line. AOM equal to AOM. Points on the mirror line are their own image and are irrelevant. Under reflection, a figure and its image are congruent. Finish today with let me finish today's study. I'm not too well for my 我喉咙不好了，我说到嘴巴干，我现在去喝水。晚上 insert my phone.